Welcome, ladies and gentlemen. And our next experiment is um, the experiment where we're going to determine that we're kind of going to finish up our study of IR. And what we're going to do is use the IR machine to get a spectrum, and you're going to use all of your skills that you applied in your homework problems to identify functional groups. And then you're going to run a series of chemical tests on your compound and use your microscale boiling point to look at a list of compounds and determine which compound that you have based upon chemical tests, your IR spectrum, and your micro boiling point. So you get to apply a bunch of skills on this experiment. Um, Essentially, what you're going to do is, I suggest that you run your IR as quickly as you can because that's going to kind of determine which test you're going to run for the experiment. Because of the fact that in this experiment, we're just trying to identify what the compound is. And the easiest way to do that is to narrow things down based upon your IR. Now, with that in mind, there's a few things you can be running. One of you can be running while one of you is running an IR, waiting in line for the IR. There are some tests that you can run. One of the tests is what we're going to do is look for, is the compound soluble in water or not? Because that's going to give us a lot of information. Typically, 3 groups of compounds are soluble in water, and those would be amines. Will give you a pH greater than 8 if you test the pH after you get it dissolved. Please understand here, it must dissolve before you run this test. If the compound dissolves in water and you run a neutral test, you have some probably low molecular weight ketone or an aldehyde of some sort, usually 5 carbons or less. If it comes up acidic, when you do this, almost always you have low carbon, 5 usually, or 6, maybe less than that, carboxylic acid. So that's the first test you want to run. So typically, when that test is run, you can determine a couple of the compounds. So if you could see that you had a spectrum for carboxylic acid, and your compound was water soluble and the pH was less than 5, that's probably not enough evidence, but that's probably narrowing me down to the carboxylic acid groups. If you look for those peaks up around 3,400 or so for the amines, if the pH is above 8, and typically amines have a terrible smell to them, you might be able to narrow it down to that at that point. And then what you're going to do is go run some other tests. Now, you can run these tests. They're not listed in the book for other solubilities. I'll make this document available to you. I'll send you the link to this document if you want to have it available. It is okay if you want to run some of these other tests. Now, typically what we're going to do is the book, in the back of the book, there's a bunch of tests listed. This is an exhaustive list of tests here. So I have limited your compounds to ketones, carboxylic acids, amines, aldehydes, alcohols, and alkenes. Alkene is not listed in this list. Yeah, so we also will have alkenes. You have a bunch of tests listed. I'm not going to go through every test here. The tests are pretty much self-explanatory in the listing, but there are specific tests that apply to certain functional groups. For example, the 2,4-dinitrophenylhydrazine test is a very good indicator of if you have a ketone or not. It'll tell you if you have an aldehyde or a ketone. And then there's some other things you can run for that. Alcohols, one of the tests we're going to run is a chromic acid test, and we're also I think we have the Lucas test available also. Aldehyde, you got the chromic acid test and the 2,4-dinitrophenylhydrazine test. These are all listed. There's a listing of them back in a section of the text. You don't really have to go there. In the experiment itself, there are listed most of these tests, and you can do them. There's one for, and yeah, it's not listed here either. If you have a halo alkane with a halogen on it, there's a specific test that you use a copper wire, and you look for this green color when you have to set the copper wire on fire. So if nothing else is working and you don't see a lot in your spectrum, you may start looking that way pretty quickly. So there'll be a listing of potential candidates for the compounds. Um, you can run your boiling points to kind of narrow that down on the compounds. You run your groupings, your grouping tests, which there are, maybe 8 or 10 of those, and you run your IR, and you should be able to identify your compound. That will end our treatment of the infrared spectral photometer. We've done about 3 or 4 labs now with it. We will use it at other times. It won't be the focus of the rest of the semester. So this will kind of end that for us. So just read over the test. You just need to be familiar with them. There is of which one applies to which chemical. I know that there might be a couple of you that have an older textbook, and a couple of the tests I think were misprinted in the first edition if you have it. So let me know on that. And you may have to search someone's second edition out on a couple of the tests, and I'll try to verify that. I'm going to have to dig out one of my old first edition books to see where the text differs. So we'll see you Thursday. Um, be prepared to run a bunch of tests and be prepared to get on that IR as quickly as you can to narrow down what tests you probably are going to have to do. Warning right up front, you're going to get a bottle full of the chemical. Guard it because those chemicals, in a couple of the cases, I ran out of your chemical. I can't refill your bottle. So use them sparingly. The amount that it tells you to use for the test, do that. Remember, you only need a couple drops for the IR. If all else, and you need a couple drops for the melting point test. So with all that in mind, we'll go there Thursday and go for that. So see you then, and good luck on your identification.